All right. So to get things started, for this joining us live, welcome, and for this, listening in or watching on YouTube. So today we're gonna be reviewing a paper on watermarks for large language model by John here joining us today. Thank you so much, John, for joining us. If you have any questions about the paper for John, you're able to ask those questions live in the chat today, or if you want to ask some offline questions, we'll be answering those questions on our Slack channel. To join it, you can just go to arise.com/Slack. Thank you. So I'm Dylan, your host. I'm on the developer relationship team at Arise, and I'll hand it over to Parth.
Hey everyone, I'm Parth and I'm a software engineer here at Rise. And John, I'll hand it off to you now.
Awesome. So yeah, my name is John Kirchenbauer. I'm a PhD student at the University of Maryland. I work with Professor Tom Goldstein on a variety of topics, but the thing that I'll be talking about today is sort of a series of work of papers on a sort of safety and security idea, which is watermarking generative models. So large language models, image generation models, basically the most exciting kind of technology at the center of AI today. Um, Obligatory before I get going, this is always joint work, especially with some collaborators. One who used to be a postdoc with Tom, Jonas Geiping, now a lab leader in Germany, and a fellow PhD student, Yushin Wen, who both contributed a lot to this work. So basically, I'll give a quick overview of sort of the two main papers that we did on the topic. One is watermark for language models, and the other is a watermark for diffusion or image generation models. And then, I'm sure there will be questions, but I will sort of throw out a couple ideas about like interesting directions that I think the research community is heading in, sort of following some of our work. So just to set the scene, it feels like a while ago, but we first started working on the core idea at the center of the watermarking papers way back in 2022. And it was basically with the release of ChatGPT. So up until, I guess, the fall of 2022, language models and generative models just weren't really good. At least they weren't good enough for people out in the wider public to be interacting with them or using them on a day-to-day basis. ChatGPT sort of like broke open the floodgates on that, and all of a sudden there was like a real problem where you might want to be able to tell whether or not something that you're looking at online, piece of text, an image, whatever it is, was probably written by an actual human user or whether it was maybe generated by some automated system. And there's like various reasons you might be interested in that, but imaginations almost immediately ran wild about the types of new spam that could be flooding the internet and our inboxes, or other sort of weird artifacts where once the internet was clogged up with AI-generated content, all of a sudden everything we would build in the future would now be ingesting a bunch of AI-generated content. And so watermarking was sort of a proposal to be able to add something that we could go look for later and tell real content from model-generated content apart. We started by sort of proposing that you would want a few key properties for a watermark that you would feel comfortable, using and deploying in the real world. One of the things was that you'd want it to be at least somewhat robust. So, once a model like a language model generates a bunch of text, or once a diffusion model like Stable Diffusion generates an image, that text, that image, that content is shared and broadcasted around the internet, and it's possible that when you go to try and make a decision about whether or not it's human generated or model generated, it might have been modified in some way. And so when we set out to develop our technique, that was like one of the first concerns: is what happens if the thing that was generated by the model is now modified, and then we go and try to decide whether it's AI generated or genuine human content. The next thing was we wanted it to be much cheaper than running the AI model itself. So, even a couple years ago, the sort of the frontier level AI systems were already these massive billions of trainable parameters systems that had to be run on, nodes, if not clusters of, very expensive GPU hardware. And so it was a pretty immediate concern that you wouldn't want detecting whether or not something was model generated to be as expensive as like creating it in the first place, because that would make it a little bit difficult to deploy this kind of security feature at scale. And we also thought, there's a ton of effort and investment spent like building these state-of-the-art systems. It'd be great if you could just sort of add this feature on. If you have to bake it all the way into the model creation process itself, again, you might sort of mess with the quality of the model, but you also just might not have access. If you're not the model creator or builder, it would be difficult to sort of bake this in from the ground up. And we also thought, as researchers, it would be nice if there's some good sound math at the center of this technique so that you're, able to sort of make some reliable confidence estimates rather than just sort of, giving some uninterpretable floating point 90% value or whatever it is out of the system and saying, well, that's what we think it is. Um, and so to understand the technique, you really don't need to know too much about how language models work, except for sort of at the abstract level that we often interact with them sort of on a day-to-day basis. So for our technique, we treat a language model as something that takes in some previous text, let's say a prompt, sort of a user input, and then produces more text. And the way that it produces more text is one by one, it chooses a more likely sort of next word to come after the words that were input previously, and then it does this repeatedly. And if you do this over and over again, you eventually get a lot of text as output. And so our watermarking technique was sort of built around this sort of sampling-based process where you generate text one word at a time. And the way we do it is a language model produces sort of a score, a likelihood it assigns to each possible word in its vocabulary that it knows how to use. And it's sort of a standard way to choose words is to sort of pick the most likely word to come next, put that back into the input regime, saying that's now part of the input prompt, and then do this again. And so our technique basically just gets in the middle of this process and says, we're going to create a slight change in these next word choices that the model is making. And as long as we do this in a way that is sort of like reproducible and sort of computationally implemented, we should be able to sort of reproduce this slight bias we make to this next word choice. And we're going to use that ability to actually decide whether or not when this text was generated, was it following this slightly biased series of choices that are being made? Our technique has this like sort of nice interpretation of breaking up the vocabulary of the model into green choices, good choices, red choices, less preferred choices, and basically assigning a little bit higher likelihood every single time to a subset of the tokens, the green choices for the next word. And what this means is that the model is more likely to generate one of the tokens out of the green set than the red set. At any one moment, this doesn't make much of a difference. And specifically, this is because we don't really modify the likelihood over most of the words in the vocabulary very much. We just say, out of the most likely things according to the model, make some of them a little more likely and make some of them a little less likely. We will still be choosing things that the model thinks are likely to follow the prompt. But in expectation, if enough of these choices are made following our slight biasing, breaking into green and red, then text that is generated with this system running will actually contain a surprising number of word choices that come from our sort of preferred set at every point in the text. And so we set up a nice statistical test based on this. We say that like if text is either written by a real person or generated by some model that isn't running our kind of scheme, then it's going to be half and half. Half of the time, the next word that the model chooses is green, half the time it's red. There's nothing interesting going on there. But in the cases where our system is run, then there's going to be this sort of surprising number of times where the word that appears is contained in the green set that we can sort of recompute and check at this point in the text, taking in the previous words in the passage and computing the same sort of grouping operation and checking, is the word here green or is it marked as red? And so that actually allows us to develop a nice, like, statistically grounded confidence estimate where we say it's very, very, very unlikely that this text that contains all of these preferred choices would have just been written by somebody or would have just been generated by some model that isn't running such a watermark. And so when we see that, we're able to sort of conclude, again, not with 100% confidence, but with a statistically grounded confidence estimate, that this is very unlikely to have not been generated with our watermarking procedure active. And so like I said, like we were sort of interested in the reliability, the robustness, the sort of to editing and changes to text as it sort of might appear online or is like generated by a user and then posted somewhere else and then sort of remixed. And basically what we find is that this scheme has sort of very predictable properties, which is to say, like, if you don't mess with the text, then this technique is extremely reliable. Like we will get, with a very small amount of text, a nice strong signal. Again, too many of these choices are following this green versus red rule. It's probably watermark text. But if you go and mess with it, you maybe stick it through another model. You know that this other model doesn't have a watermark running. And so it sort of paraphrases what's already here. That's going to mess up some of the choices. Or if you yourself, sit there and like, I'm gonna get rid of the signal here. You rewrite a bunch of the text, trying to maintain the meaning. Or you just say, copy a couple sentences and put them somewhere. Basically, under all these kinds of transformations, there's sort of a predictable degradation in the signal, but it just doesn't go away entirely. So if you run it through another model, it's probably still going to contain some of the word choice patterns that would mark it as green, overly green versus red, and you'll still get a signal. If a human paraphrases it, again, for the same reason, like to talk about exactly the same thing, you need to use a lot of the same words and phrases. You can move them around, but because this signal is sort of baked into the individual word choices, again, you still get somewhat of a reliable signal. And then again, as long as some significant fraction of the original generation exists, even after you copy and pasted and moved it around, well, within that region, we're still going to get a signal. And so, we thought this is great. It has a lot of nice reliability properties. Can we do this for the other big class of generative model that was sort of gaining popularity? And that's image generation models. And without getting too much into the details, the state-of-the-art image generation models today work by turning random pixel values into nice-looking pixel values. That the sort of the network, that is actually how it works at generation time. When you add your text prompt to say, I want a picture of a cute cat on a desk, well, it just combines that information with some random starting point and then, gradually denoises that random starting point into something that looks like a real nice image. We figured out a way to bake a similar type of randomness perturbing choice into this generation process as well. So sort of starting from the random noise that is going to eventually be turned into your cute picture of whatever, we just perturb that random noise a little bit, but we perturb it in a way that once the image is generated and exists out on the internet, we can run this clever sort of inversion process to turn that image back into the random noise signal that was used to generate it, or something close to it. And we can look for the pattern that we put into that random noise before the image was generated. And as long as we see enough of that pattern, then we're relatively confident that this image was probably generated from a random starting point that is our random starting point, not just an arbitrary set of pixel values. And we also look for the same kind of properties in that scheme, which is, would it work if you rotated the image? Would it work if you changed the colors of the image? Would you work if it cropped the image? And again, we sort of get predictable degradation, which is like, if you change the image too much, it won't show up as watermarked, just like if you change the text too much, it won't show up as watermarked. But at least you get a nice sort of trade-off between how much of the original sample exists and how much has it been sort of attacked or modified by the user. Feel free to stop me with any questions if you have them. A pretty quick sort of follow-up, even from, I'll say, inside the house, like other researchers at UMD was like, well, your technique is cool, but your technique only works because current models aren't actually that good. I know what, ChatGPT text looks like they use the word delve too much, and it always is too polite at the opening. And so there's some nice like theoretical work that showed like there is just a fundamental problem that like once models are fluent and capable and flexible enough to write exactly as human beings would, respond to a given task or prompt, it's going to be really hard to tell the difference between those two groups of text or those two types of images. The whole point is that watermarking is a way to sort of always try and make sure there's a little bit of a gap. Basically, you could generate any text, you could generate any image, but we're going to specifically generate this image. It has the same utility, it talks about the same things, it showcases the same concepts in the image, but because we added this little bit of controlled random perturbation to it, we'll always be able to have a little bit of a gap between, high quality model content and, genuine human content. Um, Another topic that sort of immediately there was a lot of questions floating around about, which was, okay, you're telling me you have this thing that can mark text as coming from a specific model. Well, I'm going to be able to fake that. I'm just going to look at the text that comes out of this model. I'm going to reproduce all those little specific choices that are made. And now I'm going to post this and I'm going to say, your model generated this. And it's going to have all the same little statistical signals. And now I'm going to be able to blame you, your model, your API, for having generated this content, even though maybe it didn't. It was just spoofed or forged to make it look like it has this signal. And so there's some interesting work that shows that those very specific, hard to see changes in the random choices made during generation are detectable and learnable. So if you train another deep learning system on the outputs of something that has a watermark, the watermark is sticky and it sort of exists within the outputs of that model. So now you have a little bit of like a cat and mouse game here of, motivated attackers, if they know that your model is watermarked, will be able to potentially detect or find the signal that is in there, potentially recreate it, and sort of produce outputs that look like they might have come from your system. And so just like, any good security and privacy problem, it's sort of always about defense and attacking. Yeah, so I have some other things, but I think,
Yeah.
yeah, let's just
That,
open the questions now.
that is like super interesting. Thank you so much, John.
Yeah.
Yeah, and we let you go. We're all mesmerized, I think. Yeah, I do have some questions. So, you know, today, like, do you have any ways to, if you want to watermark, for example, like a specific user or a specific source, or do you have any way to like encode any sort of data into that watermark?
Yeah, so um, there's a word for the pretty old field of hiding things in other things in terms of like information theory and digital signals. It's called steganography. This is as old as like changing the first word of your poem so that, oh, there's a hidden message in that first word, or, the Enigma codes like during World War II. And so we're sort of building on a long line of research into like, what are the ways you can hide a signal within a signal? The watermarking techniques I was just talking about are single bit watermarking techniques. So what this means is that you're trying to hide a single bit of information in a sample. Is it watermarked or is it not watermarked? But with alternate schemes, there are ways to sort of hide more than one bit of information within the same signal. So you're sort of going to, for some regions of the words, you're going to encode the first, byte of your message, and then in the next part, you're going to encode the next byte. And so basically, with a sufficient amount of text or with a sufficiently large, image or a video or something, you might be able to hide, more than this one bit of signal. And so there are some techniques already that exist that are saying, let's extend these sort of next token watermarks to the case where we want to like encode some longer byte sequence or longer bit sequence into the text using the same kinds of like pseudo randomly perturbed choices. This has trade-offs, which one of the primary ones is something I already talked about, which is if the text gets corrupted, then the underlying hidden signal gets corrupted. And if your underlying hidden signal takes more of the text to be represented accurately, then it is more sensitive to any one corruption anywhere in the message. Again, this is not a fundamental or new concept. QR codes are something that actually a lot of people are familiar with, but don't realize that like it's a really cool piece of technology where even when a QR code is a little scratched up or perturbed or there's some like smudge on it, you still get the signal out of it. And that's because within the QR code, a lot of redundancy is baked in. The actual URL is encoded many times. And so multi-bit watermarking has all these same kinds of properties where yes, you are able to encode more bits of information in some long paragraph of text, but then you have the trade-off between, okay, how easy is it to reconstruct all the bits of my message under attacks and degradation and paraphrasing and stuff like that.
Awesome.
Gotcha.
Yeah, yeah. QR codes are actually fairly complex. I believe there's a video on YouTube from Veritasium that explains how they work, and they're actually a pretty amazing piece of technology. Just a follow-up on that question. So, for you to like encode that watermark consistently and being fairly sure of the quality of the output, do you have like a minimum length for the text where you've seen it being successful?
Yeah, that was basically the opening figure of our paper was to say like the strength of the watermarking signal is going to directly be a function of how many tokens worth of generation you were able to, like I said, slightly perturb. And so we actually thought it was by construction. We knew what we were doing when we did it, but a nice property is that you want the confidence of your watermarking detection to grow smoothly with the size of the input. And so that also means that like at the very limit of almost no text has been generated, there's going to be very little signal. And a way to think about that is just to say like, okay, if you're somebody who does handwriting analysis, like you're very familiar with exactly the way that somebody writes or the way that, the word choice that they make, if you see just the word you probably don't know very much. I mean, maybe the way they write their T is extremely indicative of who it is, but basically you sort of like you need more observations to reduce the likelihood of a false positive, basically saying like, I think this looks like the watermark, but I've only seen a couple words. It could just be random chance. But by the time you've seen a couple sentences, in our paper, it was like 50 words, 50. So a short paragraph, a couple sentences worth of text. By the time you've seen that, the statistics say the likelihood that you would have seen all of these slightly biased choices sequentially in these 50 words is extremely low. Every time you see another word, the likelihood that that choice is by chance is dropping, and it's sort of falling off very quickly to the point where at 50 words we are getting p-values or confidence estimates that are in the order of like 1 in 10,000, 1 in 100,000, 1 in a million chance, and it just grows smoothly with the length. So if you're only generating a couple words, or if it's like a very simple factual answer, like who is the 45th president, there's really nothing to do there. You either generate the wrong words or you generate the right words, and there's going to be no choices to be perturbed by a watermark. But if it's a nice long essay, there's lots of different ways to write everything you want to say, and the watermark will choose one specific version, and that version, you'll be able to detect later.
Awesome.
Awesome. I have a question, and it's so you mentioned that cat and mouse game, right? Like these elements that watermarks produce can, are sticky and they can be trained on. And I was actually curious about some of the kind of industry applications and whether this cat and mouse game you're talking about is kind of a hindering factor, or I was curious about some of the other things, some of the other barriers.
Yeah. I think that the best thing I can point to is
Mhm.
I don't know if people saw Google made a pretty big announcement at the end of last year about their big production ready watermarking scheme. They have nice branding. It's called SynthID.
Mhm.
I actually was a Google intern a couple of years ago, sort of while some of this work was being developed, and I watched the nice what I want to say is like good internal competition where they were trying a lot of things out. There were different teams competing for like whose technique was going to be the deployment scheme, and eventually the thing that resulted in a Nature paper and is now deployed on Gemini and is also actually even available as an implementation in like the Hugging Face library
Yeah.
is sort of their flagship scheme. And what's interesting there is that like there was actually a long period of time where they had already developed the scheme, but it hadn't actually been deployed on like any of their flagship systems. And there's also, I don't know if you remember the story from maybe it was 2023, when OpenAI announced that they were also, working on this kind of technique, but then, they put out some detector and then pretty quickly pulled it back. Basically, they haven't deployed, even though the technology exists, they haven't deployed any sort of watermark, or they at least haven't told anybody that there is
Mhm.
some sort of watermark in the outputs of GPT-4 or O1 or 3 or any of these models. And so I was listening to a nice podcast by the poker player Liv Bourret, and she was interviewing Scott Aronson, who was one of the other like prominent researchers that did some of this earliest work on watermarking. And she almost beat him to the point of, well, why would anybody actually run their production API with these watermarks? Because the minute that there is the ability to ping you for having generated a piece of bad content or something that happens out on the internet, that's just liability for the company. And so she basically immediately said, I don't see how any actual organization would want to run this thing, or at least would want to run it and tell everybody that they were running it. Maybe they want to have the signal out there for their own uses. They want to be able to track the usage of their models, make sure they don't train on their own, outputs and stuff like that. But they won't necessarily be incentivized to give everybody else the reliable, statistically grounded ability to say this was definitely Gemini who generated this very, improper, piece of output, or this is definitely content generated from, Imagen, like Google's image generation model. They might not be incentivized to do that. Um,
That makes sense. Yeah, that
so
definitely
that's
makes
a barrier. To me, it's like, we're the researchers, we like working on the interesting technology. But then the question is like, okay, are there actually competing incentives for sort of deploying it in a way that's going to be, useful for the public versus, useful for corporations?
makes sense. And looks like we have a couple audience questions. Um, the first one being by Duncan saying, with images, how are you able to reverse the diffusion process back to state where you can compare with your watermark? I know you touched upon it briefly earlier.
Hi,
Yeah, I mean,
Duncan.
I will say like, take a look at the paper for the technical details, but it is actually a very clever sort of a quirk, a feature of actually the core math in the
Mhm.
middle of how diffusion models work is that you're sort of predicting changes in random noise, like sort of predicting the flow from noise to signal. And just because of how that process is set up, because of how we train those models,
Mhm.
that is actually invertible. Like each step sort of has a nice computational form of like what noise was added at this step versus what noise is being taken away. There's sort of a symmetry to that process. And so it's not trivial, but you can sort of write down code that implements the inversion of the process that is transitioning from noise to images based on the weights of the model. You can sort of turn that inside out. And again, it's not perfect, but it gets you close enough to the original random noise that was used to produce the image that you can, like I said, do the comparison that's required for detection. So it's very cool, somewhat technical. Please take a look at the image and or code, if you're interested in how that's done.
Cool. Dylan, do we have time for another question or
Awesome.
time?
Yeah, I mean, happy to keep going. Parth, if you have to jump off, or John, I don't know if you still have like a little more time to answer more questions. Um,
I've got a couple more minutes.
yeah, all right.
Okay.
So the next question is from Eduardo. Can the watermarking process degrade the outputs of the model? And is there a limit for the deltas in the logic of the models, for examples, in text generation where you observed it's affected negatively the quality of the output?
Yes, there is certainly a trade-off, and it's really fundamental. If there's anything that I'm sort of proud of about the work is that some of the sort of the key trade-offs that we identified sort of have shown up in almost all of the sort of follow-up work. And one of these is this, we call it sort of like the entropy trade-off. And it's this example I was giving earlier about like, okay, is there one way to generate a satisfactory output to this prompt, or is there only or is there sort of a multitude of ways? And so that is talking about how much entropy is sort of available during this next token sampling process when you're generating the output. If there's no entropy available in the distribution, the model is extremely confident, well, then there's not so much you can do. If you make any choice other than the maximum confidence word choice, then you'll be deviating in sort of some very detrimental way. And so we have, at least in our scheme, like this tunable parameter, this delta, which is interpretable as like the amount we are moving the next token choice distribution. When it's very small, actually, as it approaches zero, nothing happens. The text looks exactly as it would have looked if you weren't running it. And then as you start to turn this up, you start to make choices that are more and more different than what the unwatermarked version of the model's output would look like. Some of the other schemes have similar, sort of tunable parameters. But like I said, it's a pretty fundamental thing. It just says like if you're generating very short, low entropy outputs, not much flexibility, it's going to be really hard to watermark them. And then in those cases, you either want to like have a very low value of that perturbation, or as long as it's a scheme like ours, it sort of automatically anneals itself for you. So I didn't have enough time to sort of get into this, but like because what you're doing is moving the likelihood values a very small amount, if the model is already very confident, your change has no effect. Basically, if the word is Barack and then the next word is supposed to be Obama, it doesn't matter what value you add to the word couch. That is not going to be the most likely choice even after that modification that you do. So it's nice that like when there's not available entropy to watermark the text, you basically don't get a new watermark. That means you can't detect it, but it also means like you're not messing with the text too much. But then in the limit where like you're generating a lot of output or it's very flexible, the model's not overly confident on any one choice, then sort of even for the same value of delta, you'll get more of the variation and you'll get more of the watermark signal. So it's a trade-off between entropy and length. And so that's a sort of a domain specific thing. And that's not just our technique, that's pretty much all of the watermarking techniques.
All right. The following question from SU. Can you talk about industry applications? And yeah, you talked about this earlier a little bit as well, but yeah, an addition from myself is that, what will be the added value from a provider to add this to their model? Because, I feel like some people would not want that watermarking to be there. And so what would be the incentive for them to be using it?
I think it's a good framing for this is like if there was one thing I could have changed about the framing and the motivation in the original work, it would have been to immediately play down the idea of like detecting plagiarism or detecting people using AI to, cheat on their high school and college essay responses. And it would have been to play up things like the thing I've talked about a couple times, which is the ability to tell model generated and genuine content apart for subsequent iterations of AI model development. So, we're sort of in this dynamical system where we're creating models, we're using them, we're putting all of their outputs all over the internet, and then we're training the next generation of models on that same internet. And so, one of the most important use cases that again could even be deployed privately and silently by companies like OpenAI or Google is to be running a watermark, even a weak one, on your models, such that you have something better than chance in when you go back and you sort of hoover up all the data on the internet for your next model, for GPT-6 or whatever it is, you have a little bit of ability to say like, okay, this bucket of text files, has a lot of this weak watermark signal that we've been running for the past couple of years. This is, we should be careful. Like we couldn't trade on this, but a lot of this is prior model generated content probably. And so, we think that sort of the traceability for future model iteration is one of the most important use cases. And it's also like one of those cats out of the bag things. You can't like put it back. Once the internet is full of content that is not watermarked,
Yeah.
there's no way to tell. This is something that you have to do proactively, while we're still building these early models. You can't fix it in post.
OpenAI, their text-generated content has been leaving a lot of like invisible like artifacts in the text that they generate. Do you believe those are watermarks? They say no, but who knows?
I mean, we like one of the rabbit holes that we dove down during the research was like Unicode, the Unicode specification, which is like the sort of the space of byte sequences and like how they render, in modern, text and the dynamic internet. Basically, Unicode has a lot of corners where there are multiple symbols that look the same, once rendered on a web page or in a browser in a document. So like those are actually like this natural like edge case where you can sort of do watermarking for free, where you're basically like replacing some symbols with equivalents that you wouldn't be able to see the difference on the browser, but it's actually a different set of bytes underneath. And as long as you're like processing the raw, strings or bytes, you can see the difference between which Unicode characters are chosen where. And so like it's very possible that they are sort of using some of those like known edge cases. But like I said, I think one of the things that's also at the core of watermarking is like the idea of like minimizing false positives. And so like in the technique, sort of we're like leaning on the side of the scale of like we don't want to be growing the detection signal at the cost of many, many more false positive estimations. And so like that's the trick is that it's very easy. Humans are pattern matching, animals. We like to see things even if there aren't things to be seen. And so like even though some of these models do seem to have noticeable quirks, I mean, this is true about real people as well. And it's really only like when you look over large bodies of outputs and you're running some sort of statistical, aggregation mechanism where you can use those features to be, somewhat confident that you're not just seeing things.
Yeah, definitely. I think we're kind of seeing some stories of like problems with like false positives today, where schools use AI detectors, and some students have been accused of using AI for their work and have lost their diplomas and certifications. And those same AI detectors, I believe like the Constitution, they put it in there and it came out as like AI generated as well. So, I can understand like how it could be a problem. But yeah, next question for PJ, is there is the technique strong enough, or will it be strong enough in the future to help legally defend cases of fair use versus copyright violation?
Hmm. I think that what's interesting to focus on there is that the space of techniques we're talking about are what I would refer to as like output watermarks. Okay, so what we're saying here is that like when a model is generating content, whether it's images, text, video, we are adding a signal to the content. And so there's sort of like a difference here between nothing is like happening to the model. It's not that there's like a watermark inside of the model or it's trainable neural network parameters. It's that the signal, the content once it's generated contains, something. And so the idea of copyright and IP infringement is a little more on the side of like the training data and how the training data is imprinted, onto the model or and stored inside of the model and potentially generated. It's not to say that like this doesn't interact with watermarking, but they are sort of like two different classes of problems. As like a sneak peek thing, I do think there is some very interesting work right now that is actually trying to use watermarks to mark content proactively such that if a model trains on it, we apply what we learned about stickiness or the sort of the fact that when models train on watermark content, they contain some of the watermark and produce it at runtime. You maybe can see how you might be able to use this fact to actually do some tracing. So, if you're very concerned about your content being used to train future generation of models, perhaps you might store it with some of it marked. Okay. And the marking wouldn't be very perceptible. To most users, you wouldn't see a difference. But if some big company runs their next iteration of model training on it, if you go carefully test that model, you might be able to, with better than, human guessing, with some statistical reliability, you might be able to say, hey, it looks like this model is generating patterns of text or images that aren't likely by chance. Like these are probably only happening because this model was training on the specific little hidden signals that I put into my content over there. So anyway, this is like kind of cutting edge stuff. We don't have like strong results, I think, on this yet, but I could see this being useful in the future.
Well, and that's a perfect transition for our last question for today. Since you're paper was published, yeah, are there any other, new developments or, new findings in the area?
I would say one thing that I didn't get to touch on today. I mean, to be frank, we're not doing too much work on this anymore. I attended the watermarking workshop. We had a finally one watermarking workshop at like a big international conference earlier this year, which was great, and like had some awesome discussions with people. Sort of like two concepts. One is black box watermarks and detection, and so this idea is like what I talked about today is where you have to have access to the generating process itself. Like you are inserting the watermark while the text is being generated at sort of a token by token level. But if it's ChatGPT or it's Gemini or if it's some other model and you're sort of a third party user, maybe you're an API sort of wrapper company, you might want to be able to do something such that you're basically piping the outputs of some big system through a watermarking process so that you're adding some signal later. So there's a whole category of papers that are trying to work on what can you do if you only have black box or query access to a system. You don't get to modify its scores, you just get to sample text from it. The other one is, like I said, this sort of like true security properties that are based on like private keys and multiple bits of signal that you're going to stick in there that could maybe be checked for and verified later. We're used to like modern internet encryption being based on I have a private key, there are public keys hosted, there's a very mathematically complicated process that allows people out in the public to check that I probably sent this message without actual access to my own like private key signature. And so there is work now that is sort of trying to use this same concept for generative AI watermarking. But like I said, it has some more fundamental issues, which are like, in order to generate these symmetric key pairs, I need to store multiple bits of signal. And to do that, now I'm dealing with the fact that I need enough text. I need the text to not be corrupted too much. But like I said, like our technique basically is simple in that like the part that allows you to add it is exactly the same information that allows us to check for it later. In production and in the future, you want schemes where the generator has some sort of private secret information. There's some sort of other secret information that is used to detect it. But having access to the detection secrets doesn't give you enough access to generate watermark content yourself, i.e., trying to really make this asymmetry stronger so that spoofing is a much harder, computational task. So yeah, some future directions in my head and out in the literature.
All right, awesome. Well, thank you so much for joining us and answering our questions today, John. That's super appreciated. And we love we really like enjoyed your paper. Your work is amazing. And thank you everyone for joining us.
Yeah, thanks for having me and for the interesting questions.
And thank you for making everything so digestible.
I try. That's a balancing act for sure.
All
See you
right.
guys.
Bye,
See you.
everyone.